So I told you the last class that NumPy library is for array computations, that you want to perform mathematical computations on arrays. Do you understand that? You want to make calculations, mathematical calculations on arrays, that is large high dimensional numbers. That is what I mean by arrays, or single dimensional numbers. Anywhere you have collection of numbers and you want to perform calculations on them, you will need the NumPy library. Do you understand that? So anyway, you have computation in large numbers, series of numbers, and you want to perform mathematical calculations on them, you need a NumPy library. Do you understand that? So then I made mention
Mm.
of, we did a lot of things creating a NumPy library. So I told you that you can create a NumPy library from a list of numbers like this. If you have a list of numbers like this, so you can with np.array, using the numbers as the argument, then you can create an arrays of numbers. Do you understand that? So this is the same numbers here, and for example, you have this is a list, a list of numbers from 1 to 0 to 9. Then here we created the numpy, the arrays, an array of numpy. Do you understand that? So we created the numpy arrays here. So what makes the advantage of this NumPy array is the same numbers of elements. It have 0 to 9, just like this. Do you understand that? It's the same numbers of items. It contains the same numbers of items, but the advantage is that you can perform numerical calculations on it. Unlike list, if you multiply list by 2, you have duplications like this. Do you understand that? You have multiplication. You don't multiply individual item. For you to perform calculations on this, you have to look through it. But for this arrays, you can perform calculation just multiply it by 2 here. It's going to multiply everything by 2. Do you understand that? So,
Yes.
so that is the advantage of using arrays. Then you can also perform higher mathematical calculations on the arrays. So if we proceed on where we stop, okay, let me start from this row. So we talk about arrays, the NumPy arrays. Then in this particular class, I'm going to give you some statistical measurement in NumPy arrays, like how to calculate the mean of arrays. Do you understand that? Mean, how to calculate the maybe standard deviation, standard deviation, and how to calculate the minimum, maximum. Do you get that? So if you want to calculate this, the minimum of arrays, like if you have an array like, let me say that we have an array of x. Let's create an array from this list. X1 is equal to maybe 10, 20, 30, 50, 70. This is a list array. This is a Python list. So I want to create arrays from here. I'll say np.array x1. Do you get that? So once I run this particular line of code, so I have these representations, but it's format of in array format. Are you following?
Yes, you're following.
Okay, so you have this particular representation in array format. So let me wait for that to run. Okay, I've not import my numpy, so I have to import it again. Import numpy as np.
Yes, thank you.
So let me run it now. So you have this representation in form of arrays. So I will now say, let me call it x1 array. So it's the same list. So if you want to find the mean or the max,
Oh,
so let's start from the main n1 array. So if you want to find the mean, do you understand that? So you can say x1 m np.mean is going to is for finding the mean. Do you understand that? So np.mean, np.mean. So you put the number you want to find at the input. Do you get that? So what you want to find is x1 array, the minimum of x1 array. I mean the average, which is the mean. So you have at 6. Do you get that? So to look for
okay.
the mean, np.mean is going to look for the mean. Do you get that? Of all items in the arrays, of all numbers in the array. Do you get
Okay.
that? So let's now move to higher dimensional arrays. If you have an higher dimensional array, like a two-dimensional array, if you have an array like this, let's say that x2. So we have a
Please, can you explain a little bit what the mean is?
mean. Mean is the average of the numbers now.
Yes.
Like if some summation of all these numbers divided by
Okay.
the length, that is 10 plus 20 plus 30 plus 50 plus
Okay.
70 divided by 1, 2, 3, 4, 5. Divided by 5. So that is what the mean is. So for this x, in this I want to explain how to use higher dimensional arrays. If you have an array, let me say two-dimensional arrays, like 3 by 3 array, something like this, 10, 20, uh, 30. So this, I'm trying to create a two-dimensional arrays. So we have this particular array in which there it's going to have a three rows. Okay, let me try to create the array np.array for us to see how it's going to look like s2. So once I run this particular line of code, so can you see that we have a 3 by 3 arrays. So for every rows there is 3 items and we have 3 rows. Do you understand that? So we have 3 columns and 3 rows. So if after you want to know the shape of this array, how do you know the shape of this array? Because I mentioned it in the last class. So let me say x2 array
That's
is dot shape.
that's it.
S2 array dot shape is going to give us the shape of this array. So it's in 3 by 3 array. So x2 array, this is what we have. So we want to look for the mean. So we can look for every mean, np.mean.
Oh,
So it's going to calculate the mean of all items. Let me try to show you the array again. S2
okay.
array. So you have something like this. So this np.mean is going to calculate the mean of all items here, just the average of all items. So but you can calculate for a particular dimension. There's an additional argument like axis. We have this axis can either be 0 or 1 because it's a two-dimensional. So if it is three-dimensional, it will be 0, 1, and 2. Do you understand that?
Oh,
So what it means is that you are
okay.
calculating. Axis means that like 1. 0 means that you are calculating for all these zeros for like the mean of this, the mean of this, the mean of this. So this is going to give us 3. Do you understand that? Why 1 means that you are calculating for all
No,
the
I don't
Hello?
I mean,
Okay, let me explain that.
zero means what?
Zero means that you are going through the zeros, the box, this particular, that means I want to find the mean of this. I want to find the mean of this. I want to find the mean of that is the box axis. So y1 means that I want to find along the vertical axis. Do you understand that? So once I run this, I'm going to have three items.
Okay.
So it means that it has calculated the mean of this, this, and this. Then you can also calculate the mean of one. If it is for one, it is for the vertical axis. So it's still three items. Do you understand that? It means that it allows you to also calculate for a particular axis instead of getting everything as a whole. Do you understand that? So let's
Okay, sir. When you say one, are you trying to refer to like 20, 10, and 50?
no, no, no. Looking at this, there are two dimensions. Do you understand that? There are two dimensions. The first dimension is that let's say that the first dimension is the x-axis. X-axis means that it's going to like this one. And I want to calculate the mean of all these row, or one, or two, and row three. Y-axis means I want to calculate the mean of column one, column two, column three. That is the two dimension.
Okay.
So do you understand that? So zero is box
Okay,
axis,
if this is two, then how can we know three dimensions, sir?
and it will be 0, 1, 2, 3.
Ah. Yes, but in what direction will the third one be going? Is it like a diagonal?
No, I think okay. I think there is you can't. Okay. And we are still going to do for that, but I'm not sure we have to use 0, 1, 2 because to get this inner, I'm still going to explain to
Just
you
trying to.
better. I'm going to explain to you better regarding the three dimension.
Okay, all right.
But look at this. For this, let's talk about the one that requires maximum. Let's do np dot max. Np dot max will give us the maximum number. Let's talk about np dot max and np dot min. Np dot max and np dot min. Np dot min. So you have np dot max and np dot min. So for example, if you want to find np dot max of everything x2 dot array, so it means I want to find the maximum of everything. So the maximum of everything is what? Is 50, Abby?
Yes.
So let's now find maximum along a particular direction, axis equal to 0. So it means that, look at this now. We are looking for the maximum along, okay, this is for colon. This first one is for colon. The first 0 is for colon. It's now clear to us
Okay.
that 0 is for column. No, the first one is like finding along this first column, which is 10, 50, and 10, which is going to give you 10. Abby? The next one is going to be 20, 10, and 20, which give us 20. And the next one is going to be 25 and 35 and 30, which is going to give us 30.
30. Yes.
So if this one now is going to find along the row, so it's going to be this 30, 50,
50.
and 30. Do you understand
30.
the difference?
Yes.
So that is what I mean by first row and second. Do you understand the difference? That is what this NP give us. It make provision for you to do that. Do you understand that?
Okay. Okay.
Do you understand that? So if it is for main, let's talk about main. So if it is for main, what are we going to get for this? If you are going to the first direction, what are you going to get if it is for main?
If it's for me,
Mm.
for the first direction, since it is column, 0, which is 10, 10, 10, 10, 5.
10, 10, 5. How about the second direction?
The second dimension will be 10, 5, 10.
So it should be 10, 5, 10. So 10, 10, 5, and 10, 5, 10. Justin, do you understand that?
Yeah, I got it.
Okay, so let's proceed. So if it is also standard deviation, you just have to use np.std. It's going to give you standard deviation like np.std. So it's going to give us the standard. That is for keyword for standard deviation of numbers. np.std like s2 array. So we have something like this. Then you can specify direction equal to 0, equal to 1, something like this. So that those are the standard deviation. Then we also, I think we should have variance. I'm going to check the keyword for variance, but let's proceed to trying to look for index maximum and index minimum. So index maximum is what I mean by index maximum is that argmin, np.argmin and np.argmin, index maximum and index minimum. So index maximum and index minimum. So if you want to find the index maximum and index minimum, let's say that you have series of, this is what I mean by index maximum and index minimum. So for our first example, which is x1, so we have an array of x1 array. Let's use this particular one, x1 array again. So if you have x1 array like this, so let's run this code. So if you want to find the index maximum, so you have going to look at the argmin. It's called the argmin, np.argmin, np.argmin, argmax, sorry. Why the index minimum is np.argmin. So this is what it means is that, so the minimum index, that is what it means. If I say np.argmin, so I'm going to get the minimum index. In this case, the minimum index is index 0. Do you understand that? So let me display that again. X1 array. So it's going to this X1 array. So the minimum index, this is the minimum value. Why the minimum index is at index 0? That is the index of that minimum value. Do you understand that? So why np.argmax is going to give us what? The maximum index. So that is 0, 1, 2, 3, 4. So it's going to give us 4. So this is it.
Sorry, I'm not too clear.
Okay, this is what it means by index minimum. Looking at this particular array, what is the minimum value?
The minimum is 10.
The minimum is 10. So what is the index of 10?
Oh, okay. 0. I understand now.
So also in my maximum, what is the maximum value of
1, 2,
70?
4.
So that is what is meant by argmin and argmax. Do you understand that?
Yes.
Okay, so and also there are a lot of functions in NumPy. We can't finish all the functions. There are lots of them. So I'll try to look at I'm trying to bring out the important functions. Do you understand that? So another functions that you'll be using most of the time might be the reshape function. The reshape function in reshaping a particular arrays. So arrays can be in different shape, but you can reshape. You have permission to reshape. Do you understand that? So what it means by reshaping an array is that looking at this particular array, we have x1 dot array dot shape. So we have this particular shape. It's in a shape of 5. Just we have a rows of 5, but the column is not specified. You can see that the column is not specified. So you can try to reshape this array using np.reshape function. So it's going to reshape it with np.reshape. So you can reshape this array. So the first argument will be the array itself, x1 array that we want to reshape, and your new shape. So looking at this particular shape, you can reshape it to 5, 1. You know that this it has 5, it can be 5, 1. So once I run this, so I have it to be 5, or 5, 1, 5. So you can still accept all this kind of shape, 1, 5, like having 5 columns and 1 rows, or having 5 rows and 1 column.
Okay.
So that is what is meant by np.reshape. Do you understand that? Or better still, so let's say that you created this one like x1 array shape 1. So this is first shape that we are using, and this is second shape. Sometimes you might need to reshape. So if you want to reshape this one to 1, 5, 1, 5. So we shaped it. So let's display what it gives us. This, okay, let me name this one shape 2. So we have shape 1 and shape 2. Shape 1, shape 2. So you can see that this is the first output and this is second output. So your shape can be in different ways. It can be in different ways. Do you understand that? You can try to reshape it in different ways. Another example is that let's have a particular example, like we have np dot let's create a one matrices of hundreds, np dot ones. So let's say that 4 comma, let's say 4, 2. So we have this one to be 4 rows and 2 columns. 4 rows and 2 columns. Let's say that x2 after x2. So looking at this, we can reshape this one x2 dot np dot reshape. Normally, this our original value. This is how it looks like, which is 4 rows and 2 columns. So I can reshape it to np dot reshape x2. So I want to reshape it to 2, 4. So my new shape is 2, 4. We can see that you can't just specify any shape anyhow. You understand? The shape must be reasonable. Normally, you have like 8 items. You store it into 2 rows, and I store into 2 columns and 4 rows. You cannot say that you want to reshape it into something that is not suitable, maybe 2, 5. You are going to get an error. You are going to get, because that particular shape is not possible. Do you understand that? Do you understand that? You are going to get an error. So, and also,
hello, sir. Hello?
I'm listening to you.
Yeah, for the formula to create the array, I didn't understand. Maybe I didn't follow it before. Can you just explain a little bit?
The formula.
What is that? np.ones.
Okay. I explained it in the last class. np.ones.
Oh, okay.
They are special. No, the first in this particular example, I said that you can create a array from a list. That is what we've been doing. With np.array, then put a list inside it as an input. But there are also some other special arrays which are like np.zeros. You can create a zeros arrays. So you just need to provide your shape, maybe 5, 5. So you're going to create the zeros arrays. Understand that, or 5, 1.
Yeah.
We only have 2 of that. Zeros and ones.
Okay.
So you can't say that dot tens or 6. We only have 2 tens, zeros and ones, and we also have np.zeros.
Okay.
And np.ones like this. So this np.1, so we have this. So for example, now if I want to populate this particular array, I want to everything to be 10. I just have to multiply it by 10. 10 times everything.
Okay.
I'm going to have everything to be 10. That is what I did here. np.1 4, 2, then multiply everything by 100. Did you get it?
Okay. Yes. Okay.
So you can reshape, but what you are trying to reshape must be reasonable. Do you understand that it must flow? You cannot say that you want to reshape an original array that is maybe 20, 1. You now want to reshape it to maybe to something that does not suit is not suitable. So let's proceed. And also there's also flatten. You can also flatten your array. So in this particular array, we have our x2. Then here we reshape x2. So I can flatten this x2. There is x2 dot array dot flatten keyword. So this is an array. It's going to take an array. You can flatten it. Flatten means that normally it's in 4/2, just like you want to flatten it. So it will not just have just 8 items. So that is the meaning of flatten. Do you understand that? So it's flatten. This is what it means by flatten an array. So we have an array.
So
Hello?
yes, I can hear you now.
Yeah, we
Hello.
can hear you now.
Hello?
Okay. So let's continue.
Okay.
So it means that flatten means that you want to flatten a particular array. Do you understand that? There's a particular original.
So we didn't get the flattened part very well. Maybe the internet something.
Okay.
Like what is flattening about?
Okay. So look at this particular array. We have you have how many items in this array? 8
One,
items,
two,
have you?
yes.
But it's in shape of 4,2. Do you get that?
Two.
Is in shape of
Oh.
4,2. That is 4 rows and 2 columns. So flattening means that you want to arrange it, make sure that they have just one particular rows. They will not have one rows. Just combine all the data together, represent them into just like you flatten a particular shape. So it's going to flatten it into like all these rows are now going to be one. All this one will be zero. All this is the first item here, and this next 4 items. Do you understand that?
Okay.
So that is what it means by flattening it. Like it's in 4,2, but flattening is going to give you just one rows. All the items will be combined together in form of just one rows. Do you understand that?
Okay. Okay.
Yeah.
Let me make another example. Let's look at this particular example, the first array, like x1, okay, x2 array, x2 array. Look at this. So you have this, if you flatten it like this, dot flatten. So you can see what it's going to give us. So you just arrange this everything in a single row. Everything is being arranged in a single row. Do you get that?
Yes.
It's very straightforward now.
Yes.
Okay, so that is that about. And there's this part, you can also transpose a particular array because this array it operates like a form of a matrices. You understand? All these matrix operations can be performed on it, like dot product, cross product. For example, looking at this, look at this particular array. Okay, there's really a lot of functions. You just have to once you start using it, regularly you'll be familiar with functions. Look at this s2 dot array. Look at this. So I can transpose it. Dot t is going to transpose the array. Dot t transpose means that rows will be columns. Column will be rows. Do you understand that? Let me try to display the original arrays first. Let's say x2 array. We run this particular line of code. So then we now say that dot transpose, this is dot t. You see that the rows is now columns here. The columns has been turned to rows. Like this one that is in this particular row, 10, 50, 10, which is in the first column, is now in the first rows, 10, 50, 10. Do you understand that? That is the
Yes.
meaning of dot t.
Okay.
Do you get that? So you can transpose a particular array. You can perform dot product, like perform dot product. You can use, and there's this other function. I think you also have np dot diag, which is going to give you the diagonal of the array, s2 dot array. So it's going to give us the diagonal of this array, which is 10, 10, 30. Do you understand that?
Yes.
So let me try to put comments here. np.t is going to what transpose the array. Then we have np dot diagonal
The
that is going to give us the diagonal of this array. Diagonal of the array. So then we also have array dot flatten. So if you have a particular array, so we use dot flatten is going to turn it into a single row array. It's going to flatten it into a single row array. Do you get that? Do you get that? So if you want to find,
Yes, yes.
let's say that you want to find the sum of the diagonal. So how are we going to find the sum of the diagonal? So we have a particular array like this x2 array. We want to find the sum of the diagonal, which is 10, 10, 30. How are we going to find the sum of the diagonal? Have I mentioned np.sum? np.sum is for sum. I haven't mentioned, did I mention it here? So
No.
you have, so for you to calculate the sum, it's just simply np.sum. So it's going to calculate the sum. Do you get that? So you can also calculate sum along a particular axis, like we did here. You understand? So you can calculate sum along an axis, like np.sum x2 array. So it's going to give us the sum of everything. While np.sum for a particular axis, axis is equal to 0, 0, which is the first axis. You can calculate for the first axis. Then you can also calculate for the second axis using the same np.sum. So axis 1. So do you get that?
Okay.
So it's very, very clear, very, very interesting. So you can do that. So my question now is that if you want to find this particular sum, the sum of the diagonal, how will I find the sum of the diagonal?
The np dot diag sum
np.sum
np dot
sum
in bracket diag no.
and it's just np.sum and np.diag.
Okay, np dot diag. Okay.
Then you first look for
Then
the diagonal, then you calculate sum.
x2 array.
You understand that?
Okay.
So it's going to calculate which is 10 plus 10 plus 30. Do you get that? Then
Yes.
this particular arrays also support array multiplications. I've mentioned that several times. For example, if you have a particular array, np.array, maybe 5, 6, 4, you can multiply it by np.array 10, 4, 2. So you can multiply these two together. So it's going to multiply individual items. 5 times 10, 50, 3 times 3, 9, 4 times 4, 16. Do you get that? So then also, if you can perform matrix multiplications like if you have this, let's say that x equal to x1, okay, let me say a equal to this and b equal to, you know, matrix multiplications very well.
Yes.
So you can see that if I say a dot transpose of a, okay, a does not even have a particular shape. It does not have a shape, or the shape is just, let me say dot shape. So it does not have a shape. So you can try to reshape it. Let's try to reshape this into a equal to np dot reshape.
Sure.
So A, comma, new shape is, I want it to be 1,3, and the next one should be, which is B, to also be 1,3. So if you have this particular arrays like A is 1,3 and B is also 1,3. So if you multiply this, you have what we had before, because there's another one to use, maybe transpose. You can see that these are matrix multiplications. It's A dot T, that is, if I transpose the first item, then I multiply it like this. If I transpose the first item, then I multiply it by B. So what will I have? Something like that. That is what I mean by matrix multiplication. Or there's also n A dot dot. I think there is A dot dot of B. So this, like, you are performing a dot product. Okay, so let's say B dot C. So it means that you are performing a dot product between A and B. So these are for mathematical computations. You understand? So in case you want to use for some other mathematical computations. Do you understand that?
Okay.
So you might not need to go far into this. For example, you want to calculate, use matrices calculations, do a lot of matrices calculation. You can do something like this. So that is that about that. So we have the time out now. So we'll come back now. Then I'll give you a practical examples. Do you understand
Okay.
that?
So if you want to do like variance now, so we just need to use VAR,
I think it's
just like
VAR.
the way we did standard deviation.
I think it's VAR, but I'm not sure. Let me see the epic of VAR S2 array. Okay, there's this variance. Yeah, compute the variance. So it's the same thing. It's variance.
Okay.
Variance is mp.var.
Okay.
Okay.
Our problem is